Hi everyone. In this video, we're going to be looking at homework 1, problem number 3. Calculate the speed to which a stationary hydrogen atom would be accelerated if it absorbed each of the photons used in the previous exercise. So, the goal here, I can start off by writing that. The goal is basically to find the speed of a hydrogen atom as it absorbs different photons. Find the speed of a hydrogen atom as it absorbs different photons. And the photons that were in the previous exercise were 600 nanometer, 550, and 400 nanometer. Now we could think about the relevant equations. Q's. Okay. So when we think about speed, we think about kinetic energy. E, kinetic energy. And we know that kinetic energy is equal to 1/2 mv squared. And we can say that this equals the energy of the photon by conservation of energy. Because the conservation of energy states that the final kinetic energy of the hydrogen atom equals the energy of the photon, or equals the energy of the photon absorbed, okay? So we have final kinetic energy of H atom equals E photon absorbed, which makes sense when you think about it, because if we assume, we assume it in the problem, it's a stationary atom. So the only way, or the only amount of energy that it's absorbing comes directly from the photon. So we're assuming that nothing is lost here. And we can say that these are equal because of that. So if we know that kinetic energy is equal to the energy of the photon, then we know that this equals 1/2 mass of the hydrogen atom times velocity squared, right? Velocity? Yeah, wait. Yes, velocity, meters per second, sorry. Okay, so since we're asking for the speed, we can take this equation and basically just solve for v. That's how I do it. You can plug it in and then divide out, but to me it's algebraically easier to just solve for v, so it all becomes plug and chug. Solve for v, and when you do that, we get v equals root 2 e photon divided by the mass of the hydrogen atom. Okay, so now we can just plug in, because we have the photon energies, and we can divide this up into 3 parts. Wavelength equals 600 nanometer, and plug and chug. V equals 2 energy of the photon. So this is where we go back to the previous exercise, because we found the energy of that photon. So we used the answer from the previous problem, which for 600 nanometer was 3.31 times 10 to the minus 19 joules. And then mass of a hydrogen atom is 1.674 times 10 to the minus 27 kilogram, all square root. And then we get 1.99 times 10 to the 4th meters per second. And the same thing follows for the next two is just plug and chug. So I'm just going to write those answers. For B, 550 nanometer, the answer is 2.08 times 10 to the 4th meters per second. And for 400 nanometer, we get 2.44 times 10 to the 4th meters per second. Now we can think about what these answers mean. We notice that as the wavelengths get smaller, these energies get higher. And we believe that makes sense because the higher energy photon that the hydrogen absorbs, the faster velocity it's going to travel. And we can see from the equation here, V is proportional to energy of the photon. So as these wavelengths get smaller, energy gets higher, and correspondingly, the velocity should get faster, which we see and makes sense.